Proper ventilation and temperature control are essential in machining production to ensure the safety of workers and maintain the quality of the products being manufactured. Let's delve into the importance of maintaining these factors. Worker safety. Ventilation, machining processes generate various airborne contaminants, including dust, fumes, and gases. These contaminants can be hazardous to workers if inhaled over prolonged periods. Proper ventilation helps remove these contaminants from the air, reducing the risk of respiratory problems, allergic reactions, and other health issues. Temperature control. Extreme temperatures, whether excessively hot or cold, can pose risks to worker safety. High temperatures can cause heat stress, fatigue, and heat-related illnesses, while low temperatures can impair dexterity and increase the risk of injuries. Maintaining appropriate temperature levels ensures a comfortable and safe working environment, promoting worker well-being and reducing the likelihood of accidents. Product quality. Ventilation. Inadequate ventilation can lead to the deposition of airborne contaminants on the machined parts, affecting their surface finish and overall quality. By maintaining proper ventilation, the risk of contaminants settling on the products is minimized, ensuring that they meet the required standards and specifications. Temperature control. Fluctuations in temperature can impact the dimensional accuracy of machined parts, causing variations in their size and shape. Additionally, temperature variations can affect the material properties, such as hardness and strength, compromising the quality and reliability of the final products. By controlling the temperature within specified limits, the consistency and precision of the manufactured parts are ensured. Proper ventilation and temperature control in machining production are not only crucial for worker safety but also directly influence the quality and reliability of the products being produced. By maintaining optimal levels, companies can create a safer working environment, minimize health risks for employees, and ensure that the manufactured parts meet the required standards and specifications. Inadequate ventilation and temperature control in machining production can give rise to various risks and hazards that can negatively impact both workers and the manufacturing process. Here are some potential risks and hazards along with examples. Health risks. Example: when machining processes generate dust, such as from grinding or cutting metal, inadequate ventilation can lead to the accumulation of airborne particles. Workers exposed to these particles can develop respiratory issues like asthma or bronchitis. Prolonged exposure to certain contaminants, like welding fumes or solvent vapors, can even cause more severe health conditions, including lung cancer or neurological damage. Fire and explosion hazards. Example: insufficient ventilation in areas where flammable substances are used, such as solvents or lubricants, can lead to the accumulation of combustible vapors. If ignited, these vapors can cause fires or explosions, endangering both workers and the facility. Lack of proper ventilation systems that remove these vapors increases the risk of catastrophic incidents. Reduced machine performance. Example: high temperatures generated during machining operations can cause thermal expansion of machine components. Inadequate temperature control can result in excessive heat buildup, leading to premature wear and tear of machine parts, decreased tool life, and reduced machining accuracy. This can result in poor product quality, increased production costs, and a higher risk of machine breakdowns. Product contamination. Example: without adequate ventilation, contaminants like dust or fumes can settle on the machined parts, leading to product contamination. For instance, if particles from machining processes contaminate electronic components, it can cause malfunctions or reduced reliability. Contamination issues can result in increased rejection rates, customer complaints, and negative impacts on the company's reputation. Worker discomfort and productivity issues. Example: inadequate temperature control that results in excessively hot or cold working environments can cause worker discomfort, leading to decreased productivity. High temperatures can cause fatigue, dehydration, and difficulty in concentration, while low temperatures can reduce dexterity and impair manual skills, affecting the overall efficiency and output of workers. These examples highlight the potential risks and hazards that can arise from inadequate ventilation and temperature control in machining production. Addressing these risks through proper control measures and maintaining optimal ventilation and temperature levels is crucial to safeguarding worker health, maintaining product quality, and ensuring the overall success of the machining operations. Exposure to airborne contaminants in machining production, such as dust, fumes, and gases, can have various adverse health effects on workers. Here are some common health effects along with examples. Respiratory issues. Example: inhalation of fine dust particles generated during machining processes, such as grinding or sanding, can lead to respiratory issues like irritation of the nose, throat, and lungs. Prolonged exposure to these particles can cause or aggravate conditions like bronchitis, asthma, or chronic obstructive pulmonary disease, COPD. Allergic reactions. Example: certain materials used in machining, such as nickel alloys or certain plastics, can release allergenic particles or fumes. Workers who are allergic to these substances may experience symptoms like skin rashes, hives, itching, or respiratory allergies when exposed to these allergens. Irritation and eye problems. Example: some machining processes produce fumes or particles that can irritate the eyes, leading to redness, itching, or even chemical burns. For instance, exposure to metalworking fluids or coolant mists can cause eye irritation and increase the risk of developing conditions like conjunctivitis or corneal damage. Toxic effects. Example: certain gases or fumes generated during machining, such as welding fumes or solvent vapors, can contain toxic substances like heavy metals, example: lead, chromium, or volatile organic compounds, VOCs. Prolonged exposure to these toxic substances can lead to systemic health effects, including damage to the nervous system, liver, kidneys, or even an increased risk of cancer. Respiratory sensitization. Example: some substances encountered in machining production, such as isocyanates used in certain paints or adhesives, can cause respiratory sensitization. Workers sensitized to these substances may develop allergic asthma, where exposure to even small amounts of the substance can trigger severe respiratory symptoms. It is essential to implement proper ventilation systems and control measures to minimize the release and inhalation of airborne contaminants. By doing so, the risk of these health effects can be significantly reduced, ensuring a safer and healthier working environment for employees in machining production. When assessing ventilation and temperature control risks in machining production, several key factors should be considered. These factors help identify potential hazards and determine appropriate control measures. While I can provide general guidance, it's important to note that specific regulations and standards may vary by country. In the context of Malaysia, the key acts and risk assessment methods are as follows. Occupational Safety and Health Act, OSHA, 1994. The OSHA is the primary legislation governing occupational safety and health in Malaysia. It sets out the legal requirements for employers to provide a safe and healthy working environment for their employees. Factories and Machinery Act, FMA, 1967. The FMA provides regulations and guidelines related to safety and health in factories and machinery operations. It covers aspects such as the design and layout of factories, machinery safety, and worker protection. Risk assessment. Risk assessment is a systematic process of identifying hazards, assessing the associated risks, and implementing control measures to minimize or eliminate those risks. The risk assessment process helps identify potential ventilation and temperature control risks in machining production. Identification of hazards. The first step in risk assessment is to identify the hazards related to ventilation and temperature control. This involves recognizing potential sources of airborne contaminants, temperature fluctuations, and other related hazards. Evaluation of risks. After identifying the hazards, the next step is to assess the risks associated with each hazard. This includes evaluating the likelihood of occurrence and the potential severity of the consequences. Determination of control measures. Based on the risk assessment findings, appropriate control measures need to be determined. These may include engineering controls, example, ventilation systems, temperature control devices, administrative controls, example, work procedures, training, and personal protective equipment, PPE. Implementation and monitoring. The identified control measures should be implemented and regularly monitored to ensure their effectiveness in controlling ventilation and temperature-related risks. Monitoring may involve regular inspections, air quality testing, and temperature measurements. In Malaysia, specific guidelines and standards related to ventilation and temperature control can be found in the Code of Practice on Indoor Air Quality and the Guidelines for Control of Chemical Hazards. These documents provide detailed guidance on maintaining acceptable indoor air quality and controlling chemical exposures in the workplace. It's important for employers and professionals in Malaysia to refer to the relevant acts, regulations, and guidelines to ensure compliance with local standards and promote a safe working environment in terms of ventilation and temperature control. To mitigate risks associated with inadequate ventilation in machining production, several control measures can be implemented. These measures help ensure the removal of airborne contaminants and maintain a safe and healthy working environment. Here are some examples of ventilation control measures. Local exhaust ventilation, LEV, systems. LEV systems are designed to capture and remove contaminants at their source. These systems typically consist of hoods, ductwork, and an exhaust fan. For example, in a machining process that generates metal grinding dust, a properly designed LEV system with a hood positioned near the grinding wheel can effectively capture and extract the dust, preventing its dispersion into the air. General dilution ventilation. Dilution ventilation involves the supply of fresh air to dilute and disperse contaminants in the working environment. This can be achieved through the use of well-designed ventilation systems that ensure an adequate supply of fresh air to the workspace. For instance, installing properly positioned supply air diffusers or vents can help ensure a constant supply of fresh air and maintain a well-ventilated environment. Ventilation system maintenance. Regular maintenance and inspection of ventilation systems are crucial to ensure their optimal functioning. This includes cleaning or replacing filters, checking fan performance, and ensuring proper airflow. For example, regular inspection and cleaning of dust collection systems in machining production help prevent blockages and maintain the efficiency of the system. Source control. Implementing source control measures is another effective way to minimize the release of contaminants into the air. This can involve modifying processes or using engineering controls to reduce or eliminate the generation of contaminants. For instance, substituting a solvent-based coolant with a less volatile alternative or enclosing a grinding process within an enclosure can effectively reduce the release of fumes or dust. Personal protective equipment, PPE. PPE should be used as a secondary measure in conjunction with ventilation systems. Workers should wear appropriate respiratory protection, such as masks or respirators, to further minimize their exposure to airborne contaminants. For example, workers involved in operations that generate high levels of fumes or gases, like welding, should wear respirators to protect themselves from inhaling harmful substances. It's important to note that the selection and implementation of ventilation control measures should be based on a thorough assessment of the specific processes, contaminants involved, and the working environment. Consulting with ventilation experts, occupational health and safety professionals, and referring to relevant guidelines and standards can provide valuable guidance in determining the most effective ventilation control measures for machining production. The significance of proper maintenance and regular inspection of ventilation systems in machining production cannot be overstated. Here are the key reasons why these practices are crucial. Optimal performance. Regular maintenance and inspections ensure that ventilation systems are functioning at their optimal capacity. This allows them to effectively capture and remove airborne contaminants, ensuring a safer working environment for employees. Air quality control. Proper maintenance prevents the accumulation of dust, debris, or other obstructions within the ventilation system. This ensures that the air quality remains high by preventing the recirculation of contaminants, maintaining a clean and healthy workplace. Equipment longevity. Regular inspections and maintenance help identify and address potential issues or wear and tear in ventilation systems promptly. This preventive approach extends the lifespan of the equipment, reducing the need for costly repairs or replacements and minimizing production downtime. Regulatory compliance. Many countries, including Malaysia, have regulations and guidelines in place regarding ventilation systems in industrial settings. Proper maintenance and inspections help ensure compliance with these regulations, avoiding penalties and potential legal issues. Worker health and comfort. Well-maintained ventilation systems effectively remove airborne contaminants, reducing the risk of workers being exposed to harmful substances. This promotes better respiratory health, minimizes the potential for occupational illnesses, and enhances overall worker comfort and well-being. Energy efficiency. Regular maintenance of ventilation systems optimizes their energy efficiency. Well-maintained equipment operates more efficiently, reducing energy consumption and associated costs. Early issue detection. Regular inspections allow for the early detection of any malfunctions, leaks, or deficiencies in the ventilation system. This enables timely repairs or adjustments, preventing further damage or system failures. By prioritizing proper maintenance and regular inspections of ventilation systems, machining production facilities can ensure the optimal performance of the systems, maintain a healthy and safe working environment, comply with regulations, and prolong the lifespan of equipment. That's all for today. We will continue on the next topic. Thank you for watching.